Hello everybody. We're going to be looking at 3.3b here, which is still rotations, but we're going to no longer make the center of rotation the origin. We're going to shift the center of rotation to some other coordinate point somewhere out there. But first, a quick little recap just to remind you. 90 degrees counterclockwise, if we go around the origin, that is a transformation that takes every single xy point and turns it into opposite of y, comma, x, while a 180 degree counterclockwise rotation takes every point and turns it into opposite x, comma, opposite y, and 270 degrees counterclockwise turns every point into y, comma, opposite of x. Also from the last section in the last video, we also know that 90 degrees counterclockwise is the same thing as going clockwise 270 degrees. Counterclockwise of 180 is the same as going clockwise 180. That's the special case. 180 degrees is going to be the same thing no matter which way we go. While counterclockwise of 270 is the same as going clockwise of 90. So no matter which version of a problem you are given, clockwise or counterclockwise, we do know for certain what the actual rotation is going to be. If we've got a point that's not the origin, what we basically do is create a fake origin and a new fake version of the picture by translating that center of rotation back to the origin. Then we'll do the rotation and then we'll come up with the new version of it. So for example, if we take a look at this first problem here, let's go fill in. We are looking to rotate this figure counterclockwise 180 degrees around the point -2, -1. So let's actually fill in -2, -1. That is the center that I want to turn this picture around. So we come back and look at the table up here. Counterclockwise, 180, will take every point and turn them into opposite of x, opposite of y. What we have to do is account for the fact that it's not the origin. We have to correct for this when we go to fill this out. So for example, let's just start with point x here. We'll fill it out at the bottom. Point X is currently located at 1, 2, 3, 4 to the left, -4, and 1 step down, -1. If we are going to turn this figure, we need to correct for the fact that we're not turning around the origin. So translate that -2, -1 over to the origin. That's easy. We'll go +2 and +1. My fake x point would be -2, 0. -2, 0. Think about what you've done. You've taken this center and moved it +2, +1. It sits on the origin now. So what you've done is simultaneously taken this x and moved it +2 and +1. That way they are still on the same horizontal. They are still 2 units apart, just like they were here. I have taken this relationship, green center dot and x, and simultaneously moved them back to the origin together. While that doesn't seem like that big of a deal when it comes to problems, what it does for us is make it, we can rotate -2, 0 around the origin real quick and easy because we know exactly what's going to happen. We know what our origin transformation is. Simply take the opposite of both numbers and be done. So let's do the same thing for all of them. Point I is located at -4, -3, but I want to move it over with the other points, so we'll move everything back to the origin. My fake point for I is going to be sitting at -2, -2. So we'll place that here, -2, -2. Point E is 1, 2, 3 to the left, and 1, 2, 3 down. -3, -3. But same discussion, I want to move it so I can correct for the fake point so that it moves and centers and rotates on the origin. That will place it at -1 and -2. So basically, instead of trying to use the points that are actually x, I, and e here, I'm going to use these ones that are, quote, fake points, because these are the ones I can rotate around the origin real quick and easy. So let's rotate them. If we actually perform the rotation of 180 degrees, according to my note up here, I'm going to get opposite x, opposite y. So they'll stay in the same order. So I have the opposite, 2, 0. I have the opposites, 2, 2. And I have the opposites, 1, 2. If I come back down here to my work, what I've done is the rotation now. So here's the rotation, and it's the list that we just created. 2, 0, 2, 2, and 1, 2. Okay, we've done the rotation around the origin. However, I need to bring everything back to where it was supposed to be. So literally, I need to undo the fake translation that I did. That's a real easy step. We added 2 and added 1 to move over to the origin. So let's subtract 2 and subtract 1 to undo that movement and be right back where I'm supposed to be. 2 minus 2 gives me 0. 0 minus 1 gives me -1. So that must be the end result for x prime. 2 minus 2 gives me 0. 2 minus 1 gives me 1. So there's the new location for I prime. 1 minus 2 to be -1. 2 minus 1 to be 1. To place E prime at -1, 1. Follow the logic in the work you see here. Fake point created by moving to the origin. Rotation done. Fake point undone, move back to where it's supposed to be. If you follow that process, you can rotate a figure around anything at that point because it's the same procedural aspect. You're gonna see in section 3.4 what's called compositions of transformations. Can you do multiple transformations in sequence? That's what rotating around a point that's not 0, 0 actually does. Translation to origin, then the rotation, translation back to where it's supposed to be. That's exactly what's going on. So let's look at a couple more examples here. If we take a look at the second one, we're asked to rotate this picture 270 degrees counterclockwise around the point 1, -1. So okay, let's build ourselves our problem here. A counterclockwise of 270 degrees would be taking every xy point and turning it into y, opposite of x. So I need to first adjust this to the origin translation, then do the rotation that's listed, then adjust it back to where it goes. So let's build ourselves our problem here. Point J is located at -1, -2. Point V is located at 2, 3, 4, -1. And point K is located at 2, -4. Step number 1, I need to create this box first. I need to adjust my values in order to get this back to where it's supposed to be on the origin. That's literally using the numbers that are in this point. I need to translate the x's -1, because I need to bring this back to 0. Then I need to translate the y's up 1, because I need to bring this back to 0 as well. So -1, +1, minus 1, plus 1, minus 1, plus 1. My fake points for that table are going to be -2, -1. We're going to have 3, 0. So there's 3, 0. And then we're going to have 1, -3. So, whoops, I put them in the wrong spots. That's my fault. This one's 3, 0. And this one is my 1, -3. So now, the rotation. Actually go do the rotation that's listed. According to the rotation, I need to flip the numbers around and take the opposite of the x value when I do. So flip the numbers around, but take the opposite of the first one. So -1 and +2, 0 and -3, -3 and -1. I have flip-flopped each one, and I've taken the opposite of the x value. -2 became +2, 3 became -3, 1 became -1. Now I need to go through and correct back for this. So where I subtracted 1 before, I'll need to add 1. Where I added 1 before, I'll need to subtract 1. I need to move this back to where it's supposed to be. So +1 and -1, +1 and -1. This comes out to be 0, 1. So we have a location for J prime, 0, 1. This comes out to be 1, -4. So we have a location for V prime, 1, -4. And this comes out to be -2, -2. We have a location for K prime, -2, -2. Notice it's the same work we did in rotation in the previous section. You just have to make the adjustment for the non-origin point first. All right, last but not least here, one more example. We have this quadrilateral, and we want to turn it counterclockwise around the point 1, 1. So let's build ourselves a list of fake points, and then we can do the rotation. As a reminder, counterclockwise 90 degrees creates a transformation that is -y, x. So let's fill out the list here. Point Y is located at 1, 2, 3, 4, and up 3, so 4, 3. Point K is located at 1, 2, 3, 4, 5, and up 3. Point B is located at 1, 2, 3, 4, 5 with no y change, so 5, 0. And point U is located at 1, 2, and then down 2, so 2, -2. Let's create the fake points first and adjust. To bring this center back to the origin requires -1, -1. So we'll subtract 1, both x and y, and adjust all of these points to their fake version. So that moves y to 3, 2. That moves k to 4, 2. That moves b to 4, -1. And that moves u to 1, -3. 1, -3. Now apply the rotation. I need to exchange the values and take the opposite of the y. So we'll make this -2, 3 for rotating it, -2, 4 for rotating it, +1, 4 for rotating it, and +3, 1 for rotating it. So we've now rotated the figure, but I need to undo the move I made earlier. I subtracted 1, both x and y, to move to the origin. I need to add 1 to both x and y to move it back to this center point. So we will add 1 to every value, both x and y, and this will be our new location. Negative 2 plus 1 is a negative 1, while 3 plus 1 is a 4. So y prime sits at negative 1 comma 4. Negative 2 plus 1 will be negative 1. 4 plus 1 will be 5. So there's k prime at negative 1 comma 5. 1 plus 1 becomes 2. 4 plus 1 becomes 5. So b's new location, 2 comma 5. 3 plus 1 becomes 4. 1 plus 1 becomes 2 to place u prime at 4 comma 2. At which point you've got all 4 of them. You know where the image is located. Get used to this pattern because it will really help you in the next section when you start doing compositions of anything. As a preview of that, imagine if you took a picture and reflected it across the x-axis, then turned it 90 degrees clockwise around the origin, then translated it plus 3 minus 2. That's what a composition of transformations will do. You'll do a step of them in sequence as you go. This is the perfect introduction to that. Translating center to origin, then rotating the picture, then translating back to what the actual true center was supposed to be. If you get used to that pattern, you'll find the next section remarkably easy to do because it'll do the same thing, but it won't be just pure rotation. It'll be all the transformations that could be chosen from. That's everything. If you have any questions, make sure to ask your teacher and see everybody in the next section.